Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Deep beneath our feet, tucked away in the silent, damp darkness of ancient caverns, lies a secret that predates the dinosaurs, the first forests, and even the very air we breathe today. For decades, geologists have been searching for a definitive birth certificate for Earth. A way to pin down the exact timeline of our planet's formation and the development of its atmosphere. While we have long used meteorites to estimate Earth's age at roughly 4.54 billion years, the details of our planet's earliest infancy remain shrouded in mystery because the Earth is a restless machine. Plate tectonics, erosion, and volcanic activity have recycled and destroyed almost all the rocks from the first 500 million years of our history, a period known appropriately as the Hadean Eon. However, a group of scientists has discovered an unlikely time capsule, tiny bubbles of water trapped inside minerals in deep caves. By analyzing the ratios of a rare noble gas called Xenon within these inclusions, they're constructing a Xenon time machine that allows us to look back at the moment the Earth was born. To understand why this works, we first had to understand the unique chemistry of Xenon. Xenon is a noble gas, which means it is chemically inert. It doesn't like to bond with other elements. This quality makes it a perfect witness to history because it doesn't change through chemical reactions. But Xenon has a secret. It comes in several different flavors, or isotopes, and the ratio of these isotopes changes over time due to radioactive decay. Specifically, one isotope called Xenon 129 is produced by the decay of iodine 129. Iodine 129 is what scientists call a short-lived radionuclide with a half-life of only about 15.7 million years. In the context of the universe, that is the blink of an eye. Because iodine 129 existed only in the very early solar system, any extra Xenon 129 we find today must have been created during that narrow window of time shortly after the Earth formed. By measuring the excess Xenon 129, scientists can create a high-resolution clock that tracks the first few tens of millions of years of planetary evolution. The challenge, however, has always been finding a sample of the ancient atmosphere that hasn't been contaminated by the air we breathe today. This is where the cave water comes in. When minerals like quartz or calcite grow in hydrothermal vents or deep underground caves, they sometimes trap microscopic droplets of the surrounding fluids. These are known as fluid inclusions. If these minerals formed billions of years ago, the water inside them remains a pristine sample of the environment as it existed back then. By crushing these minerals in a vacuum and using incredibly sensitive mass spectrometers, researchers can sniff the ancient xenon trapped inside. Recent studies of inclusions found in the Barberton Greenstone Belt in South Africa have revealed xenon ratios that differ significantly from our modern atmosphere. These samples suggest that for the first few 100 million years, the Earth's atmosphere was leaking into space at a much higher rate than previously thought. This discovery helps solve a long-standing mystery known as the Xenon paradox. For years, scientists noticed that Earth has much less xenon in its atmosphere than it should when compared to meteorites or other noble gases like krypton and argon. The Xenon time machine reveals that our early atmosphere was being bombarded by intense ultraviolet radiation from the young sun, which ionized the xenon and allowed it to be swept away by the solar wind. This process essentially labeled the atmosphere with a specific isotopic signature. By tracing this signature back through the fluid inclusions in cave water, scientists have been able to calculate that the Earth's atmosphere became closed, meaning it stopped leaking significantly, about 100 to 150 million years after the solar system began to form. This gives us an incredibly precise anchor point for the birth of the Earth as a stable, atmosphere-holding planet. Why does this matter? Beyond just satisfying our curiosity about the past, understanding the Xenon clock helps us understand how other planets might form. If we can see how the Earth retained its volatile elements like water and gas, we can better predict which exoplanets in distant star systems might be habitable. These tiny bubbles in cave water are more than just old moisture. They are the fingerprints of a violent, molten era when the foundations of our world were being laid down. As we continue to refine our measurements, the Xenon time machine will likely reveal even more secrets about the Earth's transition from a ball of magma to a blue marble teeming with life. It is a reminder that sometimes, to see the furthest reaches of our history, we don't need to look at the stars. We just need to look deep into the Earth, at a single drop of water frozen in time. For more incredible facts like this, don't forget to subscribe and turn on notifications.